All right, final exam, Unit 1 review. Name 3 collinear points. So this is just tracing, okay? So B, C, and E. B, C, E. Are those on the same line? No, they are not. They are on the same plane. They are coplanar, but they don't form a line. Now remember, a lot of your finals, multiple choice, this is how you rule wrong answers out. BHG. BHG. Are they in the same line? Yes, they are. Real quickly, EDF. No. FGA. FGA down here? No way. So there's your answer. All right. Name 4 coplanar points. BAEF. BAF. But here's E up here. So that's a no. EGHA. EGH. Then here's A down here. So that's a no. EDJC. ED. And here's JC. Those lines are, wait a minute, on the back of the box. They are coplanar. All right, name the front plane. This one's tough because it's like an optical illusion. Is the front plane this one? Or is it this one? Well, let's see which one works for our choices. CEGB. Well, here's C, E, B, and G. That is the top. EDFG. EDFG, that's the right side. BCJA. I got too much stuff here. BCJA. So BCJA. That's the left side. So hopefully BGFE. Hey, sorry. BGFA. We have a winner. The intersection of BG and GE. Here's a hint. You don't even have to look at the box. It's point G. But if you do look at the box, here's BG, here's GE. Where do they cross? 2 lines intersect at a point. What about EGF and ECD? Well, we know E for sure, but where else? So EGF, where's that? EGF, that's the right side. ECD, let's see where that is. There's D, there's E. So where's ECD? ECD, that's on the back of the box. So where is the overlap? Right here at line ED. Remember, these don't even make sense. 2 planes don't connect at a point. Think about the floor and the front wall. They don't connect just at one point. All right? A little common sense in there. What does coplanar mean? It's points on the same plane. Coplanar. Co means with, on the same plane. Okay, 7 through 10, use this figure. Name a line parallel to DH. Well, where's DH? It's right here. Now, what's parallel to that? CG, AE, and BF. So let's see what our choices are. GH. Definitely not parallel, but intersecting. Whoops. Not mean to do that. CG, where's that? That's back here. That is definitely parallel. Oops. Okay. FG, back here, that doesn't work. And AF isn't even connected on the drawing. All right, name two lines that are skewed. Now here's one where you might want to use colored pencils during the exam. BC. So here's BC. Now, skew lines cannot touch this. So that one's out, that one's out, that one is out, and that one is out. It also can't be parallel. So that is out, and that is out. So what does that leave us? It leaves us AE, HG, and DH. So let's see where those are. AD, not a possibility. GH, I said HG, same thing. BA, no. DH, yes. Name a pair of parallel planes. So ABCD, left side, and BFEA. BFEA. Nope, those are intersecting. BFEA, which is the top, and FGEH. FGEH. Again, intersecting. Oh, board's frozen. Sorry about that. Hello, error on my side with the board freezing. Okay. AEHD. AEHD, the front, and CGHD. CGHD. Again, intersecting. So always confirm you didn't make a mistake. So ABCD, left side, EFGH, right side, we have a winner. Two intersecting planes. Well, we just found a bunch of those before, but let's do it again. BFEA. BFEA, that's the top. CGHD. CGHD, those are parallel. Okay, so no. And it is worth taking this extra time to do this to get them right. EFGH, that's the right side. ABCD, left side, parallel. Not our answer. AEHD, AEHD is the front. DH, DHGC, that's the bottom. They are definitely intersecting. Moving on. R is between M and P. You can see on the drawing over here. MP is 62. Draw that in. Remember, part, whole. So to solve this, what do? We take this part plus this part equal to the whole. Simplify like terms, join like terms. 5x plus 7 equals 62. Minus 7, 5x equals 55. If we divide by 5, we get 11. Now plug it in. Now pay attention. What is it asking for? It's asking for MR. So we're just going to double that. RP, plug it in here. 33 plus 7 is 40. And just to make sure, 40 plus 22 equals 62. L is the midpoint. Ooh, important. Midpoint means that is equal to that. So all we say is 2x plus 5 equals 9x minus 16. I like to keep my x's positive, so I'm going to subtract 2x. At the same time, because there's limited space, I'm going to move the 16 over to the left. Those cancel, those cancel. I end up with 21, and here I end up with 7x. If I divide by 7, I get x is 3. Now, notice, careful. It's asking for PL, and it's asking for LQ. But remember, it could have asked for PL and PQ, the whole thing. So always be careful. But if I plug 3 in here, 2 times 3 is 6, plus 5 is 11. And I know since it's a midpoint, they're equal. But again, you got to pay attention. If it would have asked for PQ, the answer would have been 22. It didn't ask, but you have to be careful and don't ever assume and rush through it. All right, use figures to write. It says AOB is 2x minus 4. Where's AOB? That's here. A to the O to the B. So that's 2x minus 4. It says BOC is 3x minus 19. That's this one right here. And it says AOB equals BOC. So those two you can just set equal to each other. 2x minus 4 equals 3x minus 19. Again, I like to keep my x's positive, so I'm going to subtract 2x. And at the same time, I'm just going to add 19. 19 minus 4 is 15. And 3x minus 2x is simply x. So x is 15. Now what's AOB? I'm going to plug 15 in right here. 2 times 15 is 30. Minus 4 is 26. BOD, be careful. B to the O to the D. Notice what that is. That is 90 degrees. No calculation needed. BOC. Well, we know BOC and AOB are the same, so that is 26. Now careful, here's the difficult one, or challenging one, AOD. AOD is this entire part. Now the blue angle is 90. AOB in the red, we found out was 26. So together, that makes 116 degrees. Now think about it. What if it was asking for, let's say, COD? In that case, we would have taken 90 minus this 26. So always be careful, and it does help to use colored pencils to trace, so you know specifically what you're looking at. All right, this one doesn't give you a drawing, but it tells you draw a picture and show your work. So I'm going to draw a line here. It says midpoint, so I know I'm going to have this right off the bat. It says Y is the midpoint of JK. It says YK is 6x. That's this part right here. YJ is 5x plus 21. That's this part right here. So that we don't have any total. So we just say 6x equals 5x plus 21. Subtract 5x. X is simply 21. And notice it did not want us to plug it in and find out the lengths. We're done at x. All right, ABC is x plus 3. That's this angle. Whoops. That's this angle right here. X plus 3. CBD, the angle kind of in the middle, is 7x plus 11. And ABD, now careful, that's this entire angle, is 86. So what do we have? We have a part, and a whole. So that means x plus 3 part plus 7x plus 11 part equals 86 whole. Combine like terms, 8x, 3 plus 11, 14. Subtract 14, 8x equals 72. You divide by 8, x is 9. Now let's plug it in. CBD. CBD. 7x plus 11. So 7 times 9 is 63. Plus 11 is 74. ABC is x plus 3. 9 plus 3 is 12. Now I know the drawing makes it look like they're pretty close, but it's not true. But if you add 74 and 12, what do you get? 86. So it works out right. Now, it says EBD. We haven't even messed with this over here. Okay? So what do we do? Well, let's think. This is a straight line. If we know that this over here is 86, this is going to be 180 minus 86. So 180 minus 80 is 100. Minus 6 is 94. Number 20, RT bisects ARE. So right at the bat, we know this is equal to that. If ART is 17, that's this piece right here, what is ARE? Now be careful. It's not asking for TRE. It's asking for ARE, which means the answer is 34 degrees. Pay attention to what it's asking for. Okay, 21. These are not vertical angles. They're not equal to each other because they're forming a straight line, which means part, and whole is 180. So 2x minus 5, not plus, don't know what happened there, minus 5, plus 3x minus 5 equals 180. Join like terms, 5x. They're both minus 5, so that's minus 10, equals 180. We're going to add 10 to both sides. 5x equals 190. We divide by 5. Okay? X is, 5 goes into 19 3 times. And that means 8. So x is 38. But notice, it says, and find the measure of all the angles. So we have to plug 38 in here and here. So 2 times 38 is 76. 76 minus 5 is 71. Now we have two choices. We can plug it into the 3x minus 5, or we just take 180 minus 71. Either way works. Okay? So 180 minus 70, 110, which means this is 109. Okay, Unit 1, knowledge transformations. A reflection. What is a reflection? It is a flip. Well, that's a big L, F. The flip. So, reflect the following images over the x-axis. Remember, it's a good idea to mark your x-axis. And now all you have to do is count. N is 1 above, so N prime is 1 below. I is 2 above right here, so I prime is going to be right there. And M prime is 1, 2, 3, 4, 5 above, so that's going to be right there. That was horribly drawn. Now, where's I prime? Remember, be careful. It's negative 2, negative 2. M prime it's at negative 2, 1, 2, 3, 4, 5. And n prime is at negative 1, 2, 3, 4, 5. We always go left, right first, down 1, negative 1. Okay, reflect over the y-axis. That's right here. So, n prime is going to stay right here because it's on the line. Now, g, notice, is 1, 2 away this way, so we're going to go 2 over this way. Q is 1, 2, 3 away to the left, so we're going to go 1, 2, 3 to the right, and that's Q prime. And down here, x is 2 away, so we're going to go 2 away this way, x prime. So where is G prime? It's at 1, 2, 1, 2, 3, 4. 2, 4. 2 to the right, 4 up. Q prime, 1, 2, 3, and up 1. N prime, same space, same place, either one. 0, 1. We don't move left, we don't move right, just up 1. And X prime is 2 to the right, down 1. Point A, negative 3, 1. Let's put that on here. Negative 3, 1 is right here. That's A. It is reflected over the line x equals negative 1. Well, where's that line? It's right here. It's a vertical line at x equals negative 1. So this time, we're not going to count to the axis, we're going to count to here. So A is 2 to the left of that line, so we want to go 1, 2 to the right of that line. Then it's reflected over the line y equals x. Well, where's that line? That line is right here. But this is kind of a trick question because it doesn't move. It's on the line. So it is at 1, 1 after both moves. Reflect the following points over y equals x. So y equals x is this diagonal line right here. So where are we at? We have negative 4, 5. 1, 2, 3, 4, 1, 2, 3, 4, 5. That's A. 2, 0. That's B. And negative 3, 1, 2, 3, 1, 2, 3, 4. That's C. Okay? So, they're going to reflect over the line. So all you do is switch the y and the x. So A is at negative 4, 5. This is going to be at 5. 1, 2, 3, 4, 5. 1, 2, 3, 1, 2, 3, 4. There's A prime. B is at 2, 0. That's going to go to 0, 2. And negative 3, negative 4 is going to be at negative 4. 1, 2, 3, 4. 1, 2, 3. Negative 3. You just switch the y and the x and the y. Okay, translations. A translation is simply a slide. You just move stuff. Given the vector x, y, so this is going to mean left 2, up 4. Describe the translation. Left 2, up 4. Translate the following given this vector. This is going to mean right 2, down 1. So you're going to just take each point and go right 2, down 1. That's J right there. Right 2, down 1. There's W prime. Right 2, down 1. There's P prime. Right 2, down 1. There's X prime. And that whole shape is just moved. It's not going to be very good, but look. 1, 2 spaces right, and 1 space down. So where are the new points? J prime is at 2, 1, 2, 3, 4. W is at 1, 2, 3, 4, 5, 0. P prime is on the axis at 0, because we didn't move left or right, down 2. And X prime is at -1, also on the other axis, -1, 0. Okay, 7, 4. That means right 7, up 4. So let's do that little trick here. This is just going to move right 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. That's what's going to happen. But point by point, D is going to move 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. And there's my D prime. Okay? R is going to move 1, 2, 3, 4, 5, 6, 7, and up 4. Just where we had it. And Q is going to move 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, and there's my Q prime. Now where are they? R is at 2, 1, 2, 3, 4. D prime is at 1, 2, 3, 4, 5, also 4. And Q prime is at 1, 2, 3, -1. Rotation is a spin. So what is the rule for a 90-degree rotation, a 180-degree rotation, and a 270-degree rotation? All right. So I'll write these, a little bit of room here. So for a 90-degree rotation, X, Y, you move the Y to the front and make it opposite, and the X just moves over here. For 180-degree rotation, you start off with X, Y. You just make each of them opposite. And for a 270 rotation, you have X, Y. That's kind of the opposite of 90. The Y and X switch, but the X becomes negative. So, in action, 90-degree rotation. Well, first off, we need the points. So, T, Y, J, K. So, T is at 1, 0. J is at 3, 0. Y is at 1, 2, 1, 2, 3, 2, -3. And K is at 3, 1, 2, 3, 4, 3, -4. So for a 90-degree, the Y is going to move to the front and become opposite, but there is no opposite of 0, and the 1 just moves. For Y, the -3 is going to move to the front and become positive, and the 2 just moves over here. For the J, again, there is no opposite of 0. The 3 just moves over here. And for K, I'm sorry, not K, X. For X, the -4 is going to move to the front and become positive, and the 3 moves here. So now let's plot that. 0, 1, 3, 2, 0, 3, and 4, 3. There we go. So this is t prime, this is y prime, x prime, and j prime. All right? 180-degree rotation. Again, it's the same as over there, so I'm just going to use the same points. I'm not going to rewrite them. So for 180, we just make them both opposite. So -1, there is no opposite of 0. For y, -2, +3. For j, -3, no opposite of 0. And for x, -3, +4. Now let's plot those. -1, 0. -3, 0. -2, +3. And -3, +4. So -1, 0, here's my t prime. -2, +3 is my y prime. -3, 0 is my j prime. And here is my x prime. Okay? Well, we need the information from the previous one, so I'm just going to rewrite that again real quickly. T is 1, 0. J is 3, 0. Y is 2, -3. And x is 3, -4. So 270 rotation. 270 rotation. The x moves, they switch places and x becomes negative. So 0, -1. J, 0, -3. Y, the -3 just comes in the front, but the 2 becomes negative. And again, -4 comes in the front, and the 3 becomes negative. So let's plot that. 0, -1, 0, -3, -3, -2, and -4, -3. So here's my t prime, here's my y prime, here's my j prime, and here's my x prime. And that's it on that one. Composition. One change followed by another. We've already done one before. So it's a slide and another slide. It's a slide and a flip. It's a flip and a rotation. Whatever. ABC has vertices 1, 3. -2, -1. And 3, -2. So A, B, C. Okay? Now it's going to translate 2, 0. So that's going to be 2 to the right and not up or down. So it's literally just moving 2 spaces to the right. So here's A prime, C prime, and B prime. Let's write those down. A prime is at 1, 2, 3, 1, 2, 3. B prime is at 0, -1. C prime is at 1, 2, 3, 4, 5, down 2. Now if you notice, those are all the same as these. We just added 2, so 1 plus 2 is 3, -2 plus 2 is 0, 3 plus 2 is 5. And the y's didn't change. That's another way of doing it. Now a reflection across the y-axis. Where's the y-axis? Right here. So we're going to count and go the other direction. So A prime is 1, 2, 3 to the right, 1, 2, 3 to the left. So here's A double prime. C prime, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Here's C double prime, and B double prime is easy because it's on the line. So A double prime is at 1, 2, 3, negative 3, positive 3. Notice that's the same as A, we're just making the x opposite. This one didn't change. And what's the opposite of 5? Negative 5. And it's still down 2. So that's a math trick of doing it. DE has vertices at 1, 3, and 3, negative 3. It's going to translate left 2, down 1. Left 2, down 1. So left 2, down 1. Left 2, down 1. So here's D prime, and here's E prime. And then it's going to rotate 270 degrees. So let's write those down first. D prime is negative 1, positive 2. E prime is positive 1, negative 1, 2, 3, 4. And now a 270 degree rotation. Remember, the Y comes to the front, and the X moves and becomes opposite. So that becomes positive, that becomes negative. So let's do that. 2, 1 is right here. There's D double prime. And negative 4, negative 1, there's E double prime. Okay, dilation. Dilation means it gets bigger if K is greater than 1, and smaller if K is less than 1. So let's put this on here. A is at 0, 0. B is at 3, 3. C is at 6, 3. Nope, it is not. Yeah, it is. D is at 6, negative 3. And 3, negative 3 right here. All right? So A, B, C, D, E. K is 1/3. That means we're going to divide every number, multiply by 1/3, or simply divide by 3. So this is going to stay 0, 0, because dividing doesn't make any difference. 3, 3 is going to become 1, 1. 6, 3 is going to become 2, 1. 6, negative 3 is going to become 2, negative 1. And 3, negative 3 is going to become 1, negative 1. So let's put those on here. There's A prime. 1, 1 is going to be here. B prime. C1 is going to be at 2, 1. And then we're going to have 1, negative 1, and 2, negative 1. So there's my E prime and my D prime. And now you just have a smaller version of the same thing. All right? Over here, J is at 1, 3. K is at 3, 3. And P is at 2, 1. Little triangle. J, K, P. Now, we're going to multiply everything by 2. So this is going to become 2, 6. K is going to become 6, 6. And 2, 1 is going to become 4, 2. So 2, 6, 6, 6, and 4, 2. And there's my J prime, my K prime, and my P prime. And it's just a bigger triangle, and it's moved up and over to the right. Symmetry. Determine if each figure has line symmetry, and if so, draw all the lines of symmetry. So, this one you can fold top to bottom. You can also fold left to right. And that's it. This one is a no. This one's tricky. It looks like the top matches the bottom, so that's not what I wanted. We're just going to draw a line and say, yeah, it folds top to bottom. So it has one line of symmetry. That's not what I want to do. I want to move, nope. I want to move the line. There we go. It's not, there we go. Close enough. You know what I mean. Determine if it has rotational symmetry. If so, state the order and the magnitude. This one looks like it might be a kite, but the answer is no. This one, you could flip it 180 degrees, have it upside down, so that would work. So for this one, since it could spin 1 time and be upside down, and then 2 times to come back up, and then 360 divided by 2 is 180 degrees. Now this one over here, definitely yes. This point could go here, 1, 2, 3, 4, 5, 6, 7, and then back on itself, so that's 8. And then you just have to take 360 divided by 8, which is 45 degrees. And that's the magnitude. And that's it.